Now, we're going to take up one more problem, the problem number 32. A horizontal rigid beam, ABC, 5 meter long, is hinged at A and supported by vertical props of BD and CE at B and C, which is as shown in the figure. So, we have a rigid bar having the vertical columns, which is of BC, BD and DCE, which is supported at B and C as shown in the figure. The beam carries a load of 20 kilonewton at the middle of BC. So that is at the middle of BC, it will going to carry a load. Modulus of elasticity of BD and CE are 1 into 10 to the power of 5 Newton per mm square and 2 into 10 to the power of 5 Newton per mm square. Find the load transmitted by the props. So here the area of cross section is A1, which is 1000 mm square, and area of cross section of 2, which is 2000 mm square. But the length of the props are equal, which is L and L. And this is of 4 meter long and this is of 2 meters long. Now here, so once you consider that, so here the total is AB, which is 4 meter long, and AC, which is 6 meters long. So the deflections, what you are getting at BD will be delta BD, and deflection at the prop, which is C, which will be delta CE. So now, how to, by similar triangles, as the beam is rigid, it will not deform, and hence the props will deform. So as the beam is rigid, the rigid beam will not going to deform, hence only the props will going to be deformed. That is delta BD and delta CE. So from the delta BD and delta CE be the deflections of the props of PD and CE respectively. So from the above figure shows the position of the rigid beam. So this is after the application of load. AC is the rigid beam and the props will going to be deflected by delta BD and delta CE. So as we by the similar triangular principles, delta BD by 4 will be equal to delta CE by 6. So that is, in other words, delta BD by delta CE will be equal to, what is that, 6 by 4, which will be, or 4 by 6. So what is that? Delta BD by 4 will be equal to delta CE by 6. So once you are considering that, which will be delta CE, delta BD by 4 will be equal to delta CE by 6. So on cross multiplication, delta BD by delta CE is equal to 4 by 6, which is equal to 2 by 3. So therefore, delta BD will be equal to 2 by 3 into delta CE. So delta BD, also delta BD is what? Which is equal to load PBD into L1 by A1 into E1. So delta CE will be equal to PCE into L2 by A2 into E2. So PBD into L1 by A1 into E1 will be equal to 2 by 3 into delta CE. Substitute these values, PCE into L2 by E2 into E2. So that is PBD into what is the length of BD, which will going to be L by area of cross section is 1000 into 1 into 10 to the power of 5, which will be equal to 2 by 3 into PCE into L, again 2000 into 2 into 2 10 to the power of 5. So LL will get cancelled. So PCE on simplification will be equal to 6 times PBD. So then taking the moments about the A, considering the equilibrium is in the equilibrium condition. So what is that? We will come back to this. So here we have the load which is acting, so which will be equal to 20 into 5. So where we will going to get that? So 20 into 5 here. So 20 into 5 here, actually you have, since it is at the middle portion, so 20 into 5, because it is exactly at the middle portion what it is acting, which is 2 meters length. So you are going to get 1 here, taking the moments about the point A, which will going to be 20 into 5 will be equal to, as the load is acting downwards. So in order to keep it in the equilibrium condition, you will going to have the upward reactions. So from the both clockwise moment will be equal to anti-clockwise moment, which is PBD into 4 plus PCE into 6. So that is what you will going to get. So now once you get that, so 20 into 5 minus PBD into 4 minus PCE into 6 will be equal to 0. So that is what we are getting. So what I told, it is sum of the clockwise moment is equal to sum of the anti-clockwise moment. It is again which is going to give the same thing. So 100 minus 4 times PBD minus 6 times PCE. PC is nothing but 6 times PBD, which is equal to 0. So on simplification, PBD will be equal to 2.5 kilonewton. So once you get that, so PC is equal to 6 times of PBD, 6 into 2.5, which will going to be 15 kilonewton. So this is how you will be able to solve this problem. Now we go for the one more problem. A rigid bar of ABCD is hinged at A and supported in a horizontal position by two identical steel wires, which is as shown in the figure. So here we have ABCD is hinged at A and supported by in a horizontal position by two identical steel wires. So one is PE and other one is CF, wherein as the load is applied, a vertical load of 50 kilonewton is applied at the point D, which is downwards. So naturally, as the deflection, since it is acts like a cantilever, so it deflects downward direction. In order to keep this bar in equilibrium condition, you should have the force which is acting upward direction. Therefore, T1 and T2 are both in the strings are acting upward direction, T1 and T2, in order to keep this beam in equilibrium position. So find the tensile forces which is T1 and T2 induced in these wires by the vertical load. Yes. Also find the stresses induced in these wires. If the cross-sectional area of each wire is 5 mm square. So both will going to have same 5 mm square. So now, as we want to do this, so here, what will going to be the deflections, what will going to be takes place. As the load is acting downward, since it is in the cantilever, so the beam will going to bend in the downward direction. Let delta 1 is the deflection at the EB wire and delta 2 is the deflection at the T2 wire, that is the CF wire. So as we know, this delta 1 which is equal to BB1 and delta 2 is at CC1, and here the deflection which is DD1 which is delta 3. Now as we know, as these three as the wires are identical, A1 is equal to A2 and L1 is equal to L2, E1 is equal to E2. So from the similar triangle principles, what we are going to get is delta 1 by delta 2 is equal to 1 by 2. How do I know that? So we go back to this, which will be delta 1 by 1 will be equal to delta 2 by 2. So as we want delta 1 by delta 2, so delta 1 by delta 2 will be equal to 1 by 2. So here, if you are considering that, so delta 1 by 1 will be equal to delta 2 by 2. As cross multiply, delta 1 by delta 2 will be equal to half. So delta 2 will be equal to 2 times delta 1. So also what is delta 1? P1 into L1 by A1 into E1. Here P1 is nothing but the tension in the wire, steel wire, T1 into L1 by A1 into E1, and delta 2 is equal to T2 into L2 by E2 into E2. So you substitute these two equations or two formulas here. Delta 2 is nothing but T2 into L2 by A2 into E2 is equal to 2 times delta 1 is 2 into T1 into L1 by A1 into E1. So as we know, A1 is equal to A1, L1 is equal to L2, E1 is equal to E2. So everything will going to be get cancels and T2 is equal to 2 times T1. Taking the moments about the point A. So what is that? 50 into 3 minus T1 into 1 minus T2 into 2, which will be equal to 0. So that is what we will going to get. How do I get this? So to get this, we have to go to this particular sketch, which is here. So taking the moments about the point A, sum of the clockwise couple will be equal to sum of the anti-clockwise couple. That is 50 into 3 is equal to T1 into 1 plus T2 into 2. So that is T1 plus T2 will be equal to, so that is the value what you will going to get here. 150 is equal to T1. So once what we get is so T1 into 1 is equal to minus T2 into 2 is equal to 0. So 150 minus T1 minus T2. What is T2? 2 times T1. You substitute that. It will be equal to 0. So we are going to get the tension in steel wire, which is T1 will be equal to 30 kilonewton on simplification. So what is T2? T2 is equal to 2 times T1. 2 into 30. That will be equal to 60 kilonewton. So what is the stress in the wire? Sigma 1 will be equal to T1 by A1. You know T1 is 30 into 10 to the power of 3 by 5. So which is 6 kilonewton per mm square. If it is in 6 into 10 to the power of 3 Newton per mm square. So similarly, stress in the wire of CF, because we need to find out the stresses, sigma 2 will be equal to T2 by A2, which is again 60 by 5, which will be equal to 12 kilonewton per mm square. If you want to express in Newton per mm square, it will be 12 into 10 to the power of 3 Newton per mm square. So this is how you will be able to solve this particular problem. Thank you.